Hello students, this is Mrs. Cow, and in this video you're going to learn a little bit about chemical bonds. As you know, I've always been fascinated with the fact that everything in our universe is made up of elements that are carefully organized in the periodic table. In this video, we will learn how some of these elements combine to make everything in our universe. You will have some questions to answer, and you will also need your periodic table as you watch this video. So it's important to first answer this question: why do atoms bond with each other? In fact, in nature, most elements have already reacted, and very few of them are found in their natural state. Elements are often locked together in rocks and salts. The reason why elements react or bond is to reduce their overall energy and become more stable. The atoms of most elements form chemical bonds because the atoms become more stable when bonded together, and their positive and negative electrical forces attract each other so they can form a chemical bond. And all of these are done, or all of this attraction and bonding happens with electrons that, especially in their last energy level. And these electrons are called valence electrons. One thing that's important to mention is when two or more atoms bond, they make something called a compound, like sodium atom and chlorine atom make sodium chloride, but when they do that, they have completely new properties. Sodium is a metal, it's shiny, conductive, highly reactive. Chlorine is a yellow-green poisonous gas, but when they react and form salt, they have completely new properties. It's edible, it's safe, it's something we depend upon. So valence electrons do this. They form chemical bonds. So what are valence electrons? Valence electrons are electrons in the outermost energy level, outermost shell in the Bohr model. And all atoms want to have the electron configuration of noble gases because they have a complete valence shell. For example, helium has 2 electrons and neon has 8 electrons. In fact, if you look at the valence electrons of all noble gases, they have 8, which is a complete energy level, or 2 in the case of helium because helium only has 1 energy shell. Valence electrons are easy to figure out. They are based by group number. So all the elements from hydrogen to francium are in group 1, so they have 1 valence electron. And all the elements from beryllium to radium in group 2 have 2 valence electrons. Go ahead and try these questions. Try to figure out the valence electrons for all these elements. Press pause because I'm going to give you the answers next. So what do these valence electrons trying to do? So they are trying to reach a maximum number of electrons in their energy level, in which case it's either 2 or 8. Typically it's 8, which is why this rule is called octet rule. But in the case of small atoms like hydrogen, helium, lithium, beryllium, they tend to only have 2 because they only have 1 energy level. So the octet rule is that atoms tend to gain, lose, or share electrons. So they all have typically 8 electrons, or 2, in their last energy shell. Essentially, all atoms are trying to look like noble gases because noble gases are very stable, and that's why they are chemically inert. And the way we decide where the electrons go is by this number that's called electron affinity. And that basically means the likelihood of an atom gaining that electron or taking that electron towards itself. If an atom has 4 or 5 or 6 or 7 electron in its last shell, it's almost there to a complete energy level. It will have a strong electron affinity. It will pull the electrons towards it. But if an atom only has one or two or three electrons in its last shell, it'll have a low electron affinity. That means it will likely give up its electrons or not pull them towards it very tightly. So let's start with two elements, sodium and chlorine. Sodium is in group 1, so it's going to have one valence electron, and chlorine is going to have 7 valence electrons. So in this scenario, sodium and chlorine combine to make sodium chloride because sodium is going to give up one electron to its chlorine and become NaCl. So everything in group 1 combines with group 17 on a 1-to-1 ratio. One atom of sodium, one atom of chlorine, one atom of lithium, one atom of fluorine, one atom of potassium, one atom of bromine, to combine to make everything around us. You can think of sodium chloride as it gives up, the sodium gives up its one electron, it pulls the chlorine towards it because it becomes charged. It gave up something negative, it became positively charged, and it attracts each other. And that's sort of what happens in a chemical bond. Chemical bond is an attraction between two or more atoms. You can also think of it as chlorine is a big greedy thief dog that's going to take the bone away from the smaller dog, and the two dogs stick together because the bigger dog has the smaller dog's bone. This particularly is called ionic bonding. You do not need to know this term, but in this kind of a bonding, it's called ionic bond. So now look at your periodic table and take some elements from group 1 and write down what kind of combinations you can make with group 1 and group 17, specifically chlorine. Press pause, try to write 4 possible compounds. I'm going to show you the answers. So here are some possible answers. I see NaCl is repeated twice, but you can combine any element from group 1 with any element from group 17 and make a 1-to-1 ratio. One atom of group 1 and one atom from group 17. Let's take a different scenario where you have something from group 1 and group 6 or 16. So group 16 has 6 valence electrons like oxygen and lithium. Now remember, oxygen, because it's 6, it's very close to 8. It's has a strong electron affinity. It's going to pull the electrons towards it. And lithium only has 1, so it's going to easily give it up. But if lithium gives up 1 electron to oxygen, that's still not enough. We're trying to get to 8. So you're going to need one more electron or one more atom of lithium. And in this case, you're going to make something called lithium oxide, Li2O. The 2 refers to 2 atoms of lithium and 1 of oxygen. And this is going to be true for all atoms in group 1 and group 16. Whenever they combine, you're going to have 2 atoms from group 1 and 1 atom from group 16. Go ahead and try this question. Press pause because I'll give you the answers shortly. Now, let's say you started with group 16, which has 6 valence electrons, like oxygen, but then you start with group 2. Now remember, group 2 is going to give up 2 electrons, so in that case, everything from group 2 and group 16 can also combine on 1-to-1 ratio. Beryllium can give up 2 electrons, and oxygen needs 2 more electrons, so you can make beryllium oxide, BeO, a 1-to-1 ratio. Now, transition metals in between, they are a little bit complicated. So I'm always going to give you the valence electrons that are needed for transition metals. You're not supposed to figure them out yourself because you actually have to, they don't follow one particular pattern. Go ahead and try this. Figure out how many valence electrons hydrogen and oxygen has, and how would they combine to have a full energy level. Remember, the goal is to reach 8. Now, let's say you have something like boron and fluorine. Boron is in group 13, so it's going to have 3 valence electrons, and fluorine has 7. Now, fluorine can only take 1 more before it becomes stable, but boron has 3 electrons to give up. So what it does is you're going to end up needing 3 fluorine atoms to combine with boron, and that's why you get the formula BF3. You need 3 fluorine atoms because boron has 3 electrons to give up, but fluorine can only take 1 to become full. Go ahead and see if you can try this. Take group 2 elements and combine them with sulfur and figure out how they would work. Everything, remember, in group 1 has 1 valence electron. So let's say you have carbon, which is group 14. It's going to have 4 valence electrons. So carbon and hydrogen together, remember, carbon can only have 4, so it needs 4 more to become 8. Hydrogen has 1, so it can take the 1 from hydrogen, but it's going to need 4 hydrogens to combine. So it's going to combine as CH4. This is methane gas. So carbon and 4 hydrogens together make CH4. Try these questions to see if you can figure out how different atoms combine. I hope watching this video helped you understand how certain atoms combine to make everything in our universe. And this is a sort of a brief overview of how things bond, but it gives you some idea of what the atoms are trying to achieve and how some possibilities of how they can combine. Thanks for watching.